Let's say you're doing an experiment and you just got a bunch of data, but now you need to analyze it using statistics. How do you know what test to use? There's so many of them. Where do you start? Maybe I can help you make that decision a little easier. Let's go over 4 common statistics tests and when to use them. These tests are the t-test, ANOVA, chi-square, and regression. There's many other tests you can do too. You don't have to stop at just these. Think of this video as an intro or overview to get you started. Now, as far as how to conduct these tests, we'll save that for another video. For now, we'll just focus on when to use them. The test you decide to do depends on a few things, a big one being whether your data is numerical or categorical, aka quantitative or qualitative. Numerical or quantitative data are numbers, like temperature, weight, length, stuff like that, while categorical or qualitative data are labels, like color or broad categories like big, medium, or small. You should also know the difference between the independent and dependent variable, or x and y. In a typical graph, the independent variable, or x, goes left to right, while the dependent variable, or y, goes up or down. The idea is that as you change or manipulate x, y will follow. In other words, y is dependent on x, so y is the dependent variable. And the test you do often depends on whether x and y are numerical or categorical. Let's start with the t-test. A t-test is used when you want to compare an average between two groups. So let's say you go to a high school and you want to compare the average height between freshmen and seniors. You take the height of all the freshmen and all the seniors and get a mean, or average, for both of them. On average, who's taller? In this case, the independent variable, or x, is categorical. The data is split into 2 categories, freshmen and seniors. The dependent variable, or y, is numerical. It's average height, which can be a wide range of numbers. So because there's a categorical x split into 2 groups and a numerical y, it's the perfect time to do a t-test. Now it's worth noting that there are many subtypes of t-test, 2 big ones being paired and unpaired. An unpaired t-test compares averages between 2 totally different groups, like freshmen and seniors, while a paired t-test compares averages between the same group at 2 different points, like the average height of freshmen before and after winter break. It's called paired because both sets of data are paired together. Now let's talk about the ANOVA, or analysis of variance. A t-test compares averages between 2 groups, while an ANOVA compares averages between 3 or more groups. Let's say we wanted to compare the average height between all 4 grades, freshman, sophomore, junior, senior. On average, who's taller? Once again, x is categorical, but this time the data is split into 4 categories instead of 2. Y is still numerical. It's still average height. So because there's a categorical x split into 4 groups and a numerical y, it's the perfect time to do an ANOVA. But here's the thing about ANOVAs. Once the test is done, they only tell you if there's a difference between the 4 groups. They can't tell you where that difference is. So all you know is that one of the grades is taller than another one. Great, which one is it? Well, to find out, you also need to do something called a post hoc test. Some common ones include the Tukey, Fisher, Dunnett, or Sheffey test. These tests will tell you which groups are different from each other, like whether seniors are taller than juniors, juniors are taller than sophomores, and so on. If you do an ANOVA and find that there's no difference between the groups, then you don't need to do a post hoc test. There'd be no point. Alright, on to the chi-square. A chi-squared test is used when you want to compare an observed tally or frequency with an expected frequency. So basically, you count a bunch of things and then compare that number to the number of things you expect to see. Let's use the students again. This time, we just want to see how many students there are in each grade. Forget about height. Do all 4 grades have the same number of students? If not, which grade has the most? Well, we would probably expect the number of students in all 4 grades to be roughly equal. So if the school has 100 students, we'd expect 25 in each grade. So we count the number of students in each grade and then see if any grades have more or less. A really important thing to remember is that in a chi-square, we're not looking at averages like a t-test or ANOVA, only raw tallies or frequencies. For example, if we wanted to see how many freshmen and sophomores there are at one school and compare that to what we'd expect, we would do a chi-square. If we wanted to compare the average number of freshmen to the average number of sophomores across 2 or more schools, we would do a t-test. Also, with a t-test or ANOVA, the number of groups makes a difference. You'd use a t-test for 2 groups, in this case grades, and an ANOVA for 3 or more. But for a chi-square, it doesn't matter. As long as you have 2 or more groups, you're fine. So back to the first example, because there's a categorical x and a numerical y, but this number is a tally instead of an average, it's the perfect time to do a chi-square. Finally, we have regression. You use regressions when all the variables are numerical, no categoricals. So let's say we wanted to see if there's a correlation between student height and weight. Don't worry about freshman or senior or whatever, just lump all the students together. We take the height and weight of every student. So we want to know, are taller students heavier than shorter students? As students get taller, do they also usually get heavier? In this case, because all the data is numerical, it's the perfect time to do a regression. So an important thing to remember is that with the other tests, we split the data into 2 or more groups and we're looking at differences between those groups. But with a regression, all the data is combined into one group. So now we're just looking for a relationship between x and y. This is also why we can only do a regression if x and y are paired to the same group. Remember the paired t-test from earlier? Same thing here. We can do a regression on student height versus weight because we took the height and weight for a single group of students. Every student has a height and weight. We could not do a regression on, say, boy weight versus girl height because the boy and girl numbers aren't connected to each other. The x and y aren't paired. It's like asking, as girls get taller, do boys get heavier? It doesn't make any sense. Now, there is a difference between a regression and a correlation, and we can get to that in another video, but for now, just think of regression and correlation as two sides of the same coin, or a different way of looking at the same thing. For our purposes, their differences don't really matter right now. Now, what's cool is you can also figure out what kind of test you need to do just by looking at the data in a spreadsheet and seeing how it's formatted. Let's look at 4 scenarios. If you're starting with one column of data and all of it is words, that means you can use a chi-square. We can count the number of times each word appears and then reformat the data so it's words on the left and numbers on the right. Each number is a tally for how many times that word appeared. From there, you can do a chi-square test. If you start with 2 columns of data and one is words and the other is numbers, you're either going to be doing a t-test or ANOVA depending on how many different words there are. If you want, you can also reformat the data so each word has its own column. Then underneath, put all the numbers that appeared next to that word. If you end up with only 2 columns, you'll be doing a t-test. If there's 3 or more, do an ANOVA. If you start with 2 columns and they're both numbers, that's easy. Just do regression. But only if the numbers in those 2 columns are paired with each other. You can't just do a regression on any random 2 columns of numbers. Each row has to represent one data point. Like this row could be all the data for student number 1. This column's the height and this one's the weight. If you move a number in one column, you have to move the one next to it too. You can't change the order of the numbers in just one column because that would mess everything up. Therefore, if you have 2 columns of numbers and you can change the order of just one of them, then you can't do a regression because clearly those 2 columns aren't connected. Okay, now that you've done a test, what about displaying the data? What graph should you use? Honestly, it's pretty straightforward. Chi-square results can be shown in a table, bar graph, or pie chart. T-test and ANOVA results can be shown in things like a table, bar graph, or box and whisker plot. Regressions are best shown as a scatter plot. So in summary, the statistical test you use on your data depends on the kind of data you have and the question you're asking. If your x is categorical and your y is numerical, you would use a chi-square if you're comparing 2 or more groups and the numbers are raw tallies or frequencies. You would use a t-test if you're comparing 2 groups and the numbers are averages. You would use an ANOVA if you're comparing 3 or more groups and the numbers are averages. If your x and y are numerical, you'd use a regression. But again, only if x and y are paired to each other. If you found this video useful, feel free to like and subscribe. It really helps a lot. In future videos, I'd be happy to talk about how to do each of these tests and how to interpret the results, or talk about the differences between correlation and regression. I should also add that I'm not a statistician, but I am a published researcher and I've taught university biology courses that use statistics for lab activities. So I know a fair amount, but there's a lot of people that know way more than me. If there's anything you think I got wrong or any more info you'd like to add, feel free to comment below. Also, don't forget to read the description. Hope this helps. Take it easy.